Now we're going to take a look at particular applications where percentages come up. So percentages are often used as a way of quantifying a particular set of fractions. So we'll look at some of the examples. So we'll say 18% of Frank's wages are withheld for income tax. If Frank gets $3,680 per month in wages, how much is withheld in taxes? And we're going to look at this two different ways. So here we have a percent and we have an of. And so that's telling me the base is going to be the wages. And so the amount, or the thing we're looking for, is the income tax withheld. So I'm going to name my variable. The tax withheld goes in the amount place, and the wages go into the base. And then in 18 divided by 100. Well, I'm going to convert this first to 0.18. And I'm going to just highlight that it's a fraction. Right, we remember our amount over base equals percentage over 100. Well, if I'm given the percentage, I can convert that directly to a decimal. I can divide it by 100. And so I'm going to do that right off the bat. And now I'll cross multiply. So t times 1 is equal to 0.18 times 3,680. And if I run to my calculator, that's 662.4. But that's not really our answer. Our answer is $662.40, because we have to talk in terms of what we were given, is withheld for taxes each month. Now, the other way we can do this is you can do this with the setup where we have 18 over 100. And if you cross multiply, you'll get 100t equals 18 times 3680. When you divide this back out, you'll get the same answer, and you can do this in the calculator. I find it useful when doing percentages to do them as their decimal form, so that we don't have to worry about that 100 down there. And so this is a common way we use percentages. They are used as rates for withholding on taxes. Let's look at another one. Mrs. Sherman, the principal of Reading High School, counted 31 freshmen absent on one day. This is 4% of the total freshmen. what is the total freshmen? Total number of freshmen. Again, looking at our words, we have our percent and of. So our base will be the total number of freshmen, the thing we're looking for. And so this is our amount. So if we use our setup, the amount over base equals percent, and I'm going to turn my percent into a decimal right off the bat. So our amount is 31. Our base is unknown. I'm going to use F for freshman equals 4%. So I turn this to a decimal and I get 0.04. Now I'm going to cross multiply. So 0.04 times freshman equals 31. Right, because that's all over 1. And now I'll divide both sides by 0.04. And my calculator tells me that this is 775. So there are 775. Again, I want to state my answer. 775 freshmen at Reading High School. It's always important when getting a problem that bases back to the real world is to put your answer in terms of the problem. A sentence is the best because you solve something in reality, you want to state it as a real thing. Another thing we can see is what's called a percent increase. And we can sometimes we can talk about this as percent of change. We'll look for ways of dealing with decreases at other points. So the percent of increase, I'll write as P sub I, is equal to the amount of the increase divided by the original amount. All right, so P sub I is the percent increase. A sub I is the amount of the increase. And O is the original amount. So let's look at a problem using this format. Erase my blackboard. So the average size of a soft drink, soda, has increased from 13.1 ounces to 19.9 ounces in the last 2 decades. Find the percent increase. Handwriting challenge day here. Let me just. So our percent increase is the amount of the increase over the original amount. You know what? I want to change my notation here. I want to use original amount as A sub naught. It's a common thing you'll see as starting points get a 0. Now, I have the original amount. It started from this. So the original amount is 13.1 ounces. Now the increase means how much did it change? And so that is going to be my final amount minus my original. So in this case, 19.9 minus 13.1. So I can say the percent increase is 19.9 minus 13.1 divided by 13.1. Order of operations says I do the subtraction up top first. So that's 6.8, again running to the calculator, divided by 13.1. And I'm going to get a long decimal here, so I'm going to take it to 4 decimal places. But this isn't a percentage, this is the decimal form. So if I turn this to a percentage, I move the decimal place over 2 to the right, and that's 51.91%. The percent decrease runs in the other direction. So the percent decrease, put a D here, is the amount of the decrease over the original amount. So let's say Jill Stamworth decided to decrease the number of calories in their diet when cross-country season was over, right? Because you eat extra calories when you're running. From 3,250 to 2,100 per day. And so we want to find the percent decrease. So again, the percent decrease is the amount of the decrease divided by the original amount. And so in our case, the original amount, they're starting at 3,250 calories. And the decrease is, in this case, the original amount minus the final. And we do the subtraction upstairs, and we get 1,150 divided by 3,250. And I run to my calculator, again keeping 4 decimal places. But as a percent, I'll move the decimal over 2 places, and I get 35.38%. And so these are some examples of applications using percentages.